You all are able to see screen?
Yes, yes, sir.
Okay. So we started with pointer last class, right? So let's go back to the pointer and then we will come back to array. Okay, so what we have discussed till date is basically pointer is a variable which holds the addresses, right? Now let's talk about let's write a program with a pointer and see more to that. So cptr.c int main and char pointer say cptr equals to null. Okay, we'll talk about that null. And what we are going to do is basically today we are going to allocate memory from the heap. Right? We have seen in the previous classes that your pointer can hold the addresses of another variable, right? But let's see that how we are going to allocate the memory from the heap, and when we basically take allocation from the heap, what happens that time, right? So there are basically libraries for that. So when you want to uh, take memory from the heap, so we all know that malloc, calloc, and one more is realloc, right?
Yeah.
So let's take help of that one of them and say cptr equals to uh, okay, I'll talk about the malloc in uh, next steps. Let me just write this malloc. And what malloc basically does is basically just say that you want to allocate some 10 bytes of memory. So basically, if we take a look, right, so the very first thing you should familiar about the man page of anything, right? So
Yeah.
Linux has a very rich set of uh, help manuals basically. So when you say that man of man, okay, so it will give you that. So man I interface to the online reference manual. Okay, you see that, right? So it's an online reference manual. You can see anything here. So now let's go and see that man to man. Sorry, man to malloc. So three. So if you take a look here, right, it's a programmer's manual basically. So the header file for malloc is a standard library.h, right? And if you come down, basically it will. So malloc is a kind of a library for us to allocate memory from the basically this is for the dynamic memory allocation. Now let's take a signature of the malloc. So malloc, if you see what it is returning a
Word point.
white pointer, right? And this has the size underscore t size, right?
Yeah.
So basically, see, many of the interview people ask that what happens when you are going to pass a argument as a zero to this. So if you take a look at this manual page, right? Basically, if size is zero, then malloc returns either null or a unique pointer value that can later be successfully passed to tree. So it depends on the system to system. We will see that when we are going to pass argument as 0 to malloc, what happens? Okay, but let's see the syntax. So syntax is like you have a pointer which is returning as a void, and then you are basically passing one argument which is a size. So size is kind of a numeric value which you are going to enter there. Okay, now uh, since we have opened it, so let's finish this all three, and then we might be using all this uh, in our program. So if your call will be successful, right? Say the memory malloc allocates size bytes and returns a pointer to the allocated memory. So if this function call will be successful, it is going to return an address, and that will be basically what that address will be. Suppose if you are allocating 10 bytes or 100 bytes of memory, then that address will be pointing to the first byte, right? And there is a free. So the purpose of free is like when you are allocating memory from the heap, it is user responsibility or the programmer responsibility. When you see that now I'm not going to use this memory further in my program, then you can use this free call to free the memory space. Okay, which must, so if you see the free function free the memory space pointed by ptr, if you see the syntax of free, basically this is a wide the type of free is it's a void, right? It's not returning anything. So it just takes an argument which is a type pointer, and then it free that. So I will talk about how free, I mean basically how free works. Okay. So most of the interview, if you go, people ask that how free works internally. Okay. Calloc also, if you see, calloc is basically another call, which is basically allocating memory. The difference between calloc and malloc is basically when you are going with malloc, it will just allocate memory for you, but calloc will be doing the same thing, but after allocating memory, it will be initializing memory with a zero. Okay, that is the difference between your calloc and malloc. Realloc. Realloc is why do we need a realloc? Any idea? Anyone? And when we are going to use Realloc?
To resize the memory
Mhm.
allocated.
Yes. So when you're going to resize the memory, or when you're going to say that you have allocated, for an example, you have allocated 5 bytes of memory in your program, and later you are thinking that okay, let me just increase this size because this is a dynamic memory allocation, right? So you can increase the size or you can decrease the size based on your requirement, right? So realloc is for that purpose. So what happens in realloc is like when you're going to pass a pointer to that realloc, right? Say let's say that you have allocated a memory of 10 bytes, and now you think that let me make this as 100 bytes. So do you think that the realloc which is going to allocate memory for you is going, and once it will be allocating 100 bytes for you, is it going to be the same address? The first address is going to be the same address which was earlier pointing by the ptr. Question is clear to you, or I will repeat it. Say you have allocated a memory of 10 bytes, you have got a pointer which is pointing to the first byte of the 10 bytes. Now now you are thinking that let me increase this size to 100 bytes. So you are basically taking help of Realloc, and you have allocated memory for 100 bytes. So whether the pointer which was earlier pointing to the first byte of 10 bytes, is it going to be the same address of this 100 bytes also? Say you basically when you will be allocating 100 bytes again, you will be getting a 100 bytes chunk, right? So is it
Yeah.
going to be the same address?
Yeah,
It
it,
may or may not.
yes.
Mm-hmm.
Yeah, it's written in
Yes.
the man. It's same.
So why it will not be same?
So
If
if there
the
is no continuous memory, then it will be different. Otherwise, means the probability is that it will be same.
Yes. So basically, when Memory will be, so say when you allocated 10 bytes of memory, right? After, so what it does, it will be basically giving you the contiguous block, right? Basically, say you have your starting address is some 1000, so it will be 1000 to 1099, right? If you are allocating 100 bytes. Now, if earlier you have allocated say 10 bytes, now you are going to add some 90 bytes to that. So if that 90 bytes after 10 bytes is free, then yes, the pointer is going to be same. If there, if say after 10 bytes memory has been already allocated and given to some other piece of code, then you will not be able to get the same address. So what it will be doing is basically it will be allocating a contiguous block of 100 bytes, and then you can see the pointer will get changed. So so the syntax for malloc is it returns a void pointer. That is why we typecasted to character pointer here. Okay, and size uh, as an argument. So we passed here as a 10 because we are going to allocate 10 bytes of memory. Now, when we say that, so if cptr, if not cptr, then you say that return -1. Else, no need to go with else. You can go and start writing your own piece of things. So I'm going to say that printf cptr equals to %p and cptr. Okay, and now you can say that cptr equals to a cptr equals to %c. Okay, so let me add one more line here. If I'm going to say something like this, cptr equals to pointer cptr equals to z. So let's talk about this instruction. Few instructions, very simple instructions. Let's understand this and then we'll move to the complex one. Null. So null is, what is a null? You all might be familiar with the null. So what is null? What is its significance?
Null means nothing, means it's zero value.
Mhm. So if I'm writing 0 instead of null, will that be okay? I think let me just basically go for the compilation and then we will see the differences. Okay. Let's talk about CPTR and then oh, let's fix this also. Okay, and then we'll see that. So Malloc is, if you see, basically nowadays, right, the compiler is much more intelligent. Earlier compiler it was not displaying this. So we're saying that a standard library.h is missing, stdio.h is missing. Let's include that and then we'll see. So now here as include stdio standard.h. Now let's go back and see. Fine. 0 we have, I mean, now I'm going to replace this with null. Okay, you see the differences, nothing is there. But so basically 0, you can say that 0 and null is similar thing, but I will not say that null and 0 is same. Okay, view the compiler, you can see that it may creep, depends on the architecture and depends on the compiler. Okay, now, so null is basically you are going to say that in the first line number 5, 6, you are saying that you, I mean, basically we have defined, we have taken a variable of type var point to cptr, and we have initialized this to null. Now I'm going to remove this, the second, seventh line. What is going to do?
Uh, I think there will not any compilation error, but runtime will be there will be some segmentation fault or
I'm
something.
going to remove this. Then
Then it will means it will run also. Means the behavior is undefined.
mhm.
Behavior is undefined.
Okay. So let's understand these two things, right? When you basically say that uh, you take a pointer e and you do not initialize with 0 or null, what happens? Okay. So you see that basically you can see a warning cptr is used on initialize in this function. Okay. So this is one thing. So even if you are going to ignore this and you are going to proceed further, what is going to happen is you may hit a segmentation fault. Okay. So cptr is an output file for us. Okay. So we'll talk about the segmentation fault, because segmentation fault very frequently you might be seeing when you are going to work with the heap based stuff. Okay. So let's park this for timing. Now let me see that I'm going to say that now say null. So basically you are going to allocate here cptr, and now you run this. So you got an address here, which is, so let's go back to our memory stuff, and let's see that whether this memory is belonging to it or not. Okay, now basically we have to stop this program. So use a get pair, or you can go with the sleeper statement. Either one is fine. And let's see. The program name is cptr. So yes, there is an entry into this process table, and 3622 is PID. Now cat log 26, oh, sorry, 362362 maps. Just so what is the address we are getting is 5635, and then ECBD2260. Let's see that your head, is this belonging to heap range? This is the one, 55A95. Okay, 55, basically the down one, 55A95 FC1B triple zero, and then we have a 260. So if you see that this is coming in between this range, right? So basically we have got an address from the heap. Now yes, that is perfectly fine. So when you are going to allocate memory, it is going to even address from the heap. Now let's proceed further from the programming perspective. So what happens to this statement? So basically, when you are going to do this, like say cptr equals to something, right? Cptr equals to some value, right? This means that you basically, so cptr equals to null, or cptr you have not initialized with any. So what is going to happen is like it's going to, so it's not going to be a valid address, first thing, right? So even if it is going to point to some address, right? So let's see that if I'm going to remove this, okay, I'm going to remove this, and basically add a printf statement here, and then you see the address differences there. cptr might be having a 0, or might be having some other value. Okay, so cptr is person b. Now uninitialized, fine, so let's ignore this. cptr equals to nil. That means it doesn't have any address. So basically this is like, basically this is pointing to the zeroth address, or zeroth. That is why when, so when you're going to dereference the null, so we have something called dereference. So line number 9, sorry 8, is when you're going to use a pointer and you're going to assign some, say right hand side, basically after equal to operator, going to assign something. That means you are dereferencing. So basically you are going to store the value at that particular address. Okay, what is it, what is mean is like cptr is pointing to something, and you are going to store something to that address. So basically null, right? So null, if you take a look at the os code, what is happening is null is a protected one. Okay, so the zeroth address is protected one where you're not supposed to read, write anything. Okay, not only zeroth address, even if I'm going to assign some 100 or 200 address, that will not be. So the addresses which are not supposed, or the addresses which are not permissible for programmer or for user, if you're going to write something to that, you can see that as segmentation fault. Okay, that is why we'll end up into segmentation fault. So null, we all know that it is uh, the read and write permission is not there. That is why there is a segmentation fault. So when you allocated memory here 9 bytes, sorry, at the line number 9, it allocated a memory something, did not, not connected to. Okay, so basically you, I am not connected to the device, so just a minute, let me bear with me with the handwriting. So this is basically the 10 bytes memory allocated for you from the heap. Okay, that we have seen with 10 byte read from the heap. Now this 10 bytes is allocated, and the address which it is returning, right? Basically it returns, we have seen that malloc is returning a pointer type, void pointer type, right? So it returns something here, uh, and this is the first address, the first byte address which we got to ptr. Now when, so the pointer arithmetic, how it works, right? Say you got the first address, and you know the boundary, right? You basically, your pointer will not be knowing the boundary. The most important thing with the pointer is the pointer will not be knowing the boundary. How much byte, I mean, you can start traversing. Once you got the address, you can go and go. So what is going to happen is, like, once you are starting with, say, PTR, once you got the first address, you know the boundary that, okay, this boundary, this PTR is basically is going to, I mean, I have a 10 bytes valid address. Okay, I have a 10 byte valid address, which is basically we have received from Malloc. So I can go read and write to the 10 bytes. If I am crossing the boundary after 10 bytes, might be a chance that I'm going to write to some different pointer, to some different region, or to some different heap block. Okay, so this is it might be problem. It might be a problematic one when you have basically when the next region, the next addresses are basically returned to some new pointer. So in that case, what will happen? You are basically, so there will not be any segmentation fault in all. Basically, you will corrupt the data of the other pointer. So this is one thing. If even if this is not there, say this region is free, nobody is using, you can go till a limit. Okay, till the limit. And what is that limit? Any idea? Till how long you can go? Keep on writing.
Physical memory limit means whatever
Mhm.
whatever
Not
no,
Till the heap finishes.
till
means the address space of program the running process, whatever memory is available,
memory available for what?
the process.
Uh,
The
okay, since
process,
it's
your process is 4 GB address space, right? Say
Yeah.
process knows that, okay, if any process is coming to memory, he will be having entire memory for. That means you can go till 4 GB writing, read and write.
uh, if this is a dynamic memory, then it will be the heap size.
Heap,
Like
yeah, heap.
stack and heap will be together. So when it crosses the boundary of heap to stack, you will get an error.
Yes.
Crosses the boundary of heap, right? Yes, that is a very valid point. But what is the heap boundary? How do you know that? What is my heap boundary?
Heap boundary will always be set by that BRK pointer. So whenever it increases, like stack and heap will be growing in opposite direction.
Mm-hmm.
So if stack occupies more space or heap occupies more, so BRK will be setting the breakpoint over there. I
Mm-hmm.
mean the range where till
Mm-hmm.
where it can. So until that you can exceed.
Okay, okay. Yes, valid point, Kiran. So, so basically, when you are allocating memory for your pointer, right? We have seen that somewhere we have seen that the ranges of the heaps, right? So this heap, right? So whatever the addresses till this 3300, okay? If you are getting an address in between, then there will not be any segmentation fault. You try that out, okay? So this is going to be a homework for you people. You have to, what you have to do, you you don't allocate a memory. So you allocate a memory something, you will be getting a pointer. Now what you have to do, you have to uh, cross the limit of your allocated memory and see till which place you are able to read and write. Okay, if there is any segmentation fault, we'll talk about in the next class. I will be talking about what is your understanding with that segmentation fault, and then we'll take it proceed. So okay, so no, note it down. Okay, try that out. So already we have a hint Kiran has given, and you try that out. Now, so thing is like, once you get a pointer CPTR, how much you are going to travel is the size how much you have allocated for memory, right? So CPTR is a character pointer. We know that.
So
Now,
we
yes,
so so we can means increase the heap size also, right?
how you're going to increase that?
No, I'm just asking that means we can reserve heap size, heap we can increase. So whatever is showing, it might be default one, right? And we can increase it, right?
No, how you're going to do that?
How I'm going to do that? There should be some means calls, kernel calls that will reserve some certain
So,
amount per heap.
so BRK and SBRK I will be talking about in the system programming. For time being, you understand that when you are going to say allocate a memory, right? Say that Malloc you have given some 1 MB, okay, and say that uh, this is like the addresses which we are seeing here, right? It is kind of a your OS basically will be keep on. So it's a runtime allocation, right? So it is a runtime allocation you can see here, right? When you run this program, basically OS is providing a segment for you, right? And OS adjusts that. So basically, based on the program requirement, right? It will be basically it will be knowing that okay, if a function call is there, for an example, if a function call is there and it is looking for some more memory, what will be happening is like it will be keep on adjusting. So you don't have to basically one is you don't have to worry about unless there is a memory, it will be going to give a valid address for you. If they will not be or if memory will be exhausted, then it is going to return a null. Rarely you can see that it is going to return a null. Okay. So you you keep on traversing, and then so this size is important for you. Now pointer arithmetic comes into picture is like this pointer is of type CPTR. Before going to pointer arithmetic, let me also do one thing here is like I will comment this out, otherwise it will crash. Here is you just see that the size of pointer equals to percent in the size of CPU. You see the size of pointer is equals to 8 bytes. Okay, so we got, and so we all know that this is 64-bit architecture. We are working on 64-bit architecture, so pointer size is 8 bytes. If your system will be 32-bit, it is going to give you 4 bytes. So now when I'm going to say here, say we got the first address we got it here, CPTR. Now you can, so pointer arithmetic supports, what kind of arithmetic is supported by pointer? Plus arithmetic operator. What are the arithmetic operator, by the way?
Plus, minus, multiplication, division.
Mm-hmm. Modulo, right?
Yeah, modulo.
So pointer is basically when you are going to, basically it is supporting only two things, plus and minus. Okay, or you can say that plus plus or minus minus some. So if I'm going to say that CPTR equals to CPTR plus 2, and now you see that, so your CPTR, what will happen here with this statement, this highlighted statement, how many bytes it will be increasing?
16.
Okay,
Sorry. Okay, so it is pointer character, right? So it is just 2 bytes.
Say if your CPTR is base address of CPTR is 100, then what will be the next
102.
address? Okay.
Uh,
102.
basically, basically it increases for 16 bytes. If address is 100, it will be 116. Since pointer size of a pointer is 8 bytes and in incrementing by 2, so then it will be 2 bytes. Sorry, it is yeah 2 bytes.
We're not increasing. So okay, so you need to understand two things, right? I mean, CPTR is a pointer of what type?
Character.
Character, right? So when you are doing an arithmetic, basically, what type of pointer it is? Okay, first thing is, it always think about when you are doing arithmetic, it will first go and take a look at what type of my pointer is pointing to. My pointer is a type character, and we know that character is basically one byte. So if you are doing any arithmetic here, plus that means it is going to be CPTR plus 1 is going to be the next address plus 2 is going to be the next, right? Now let's see that. So uh, okay, so let me, before going here, I will just show you something here. So for, we are going to traverse this pointer, right? I is less than 10, and I'm going to say that I CPTR. So when I equals to 0, we want to traverse. I'm going to say that CPTR plus 0 equals to first address plus 1 equals to next, and so on. Now see that. So you see that 70, 71, 72, 73, right? So when you are 0 is basically the same, right? You add something to 0, it will be same. When you are adding 1, it is going to be. So when you are going to do the CPTR equals to CPTR plus 2, it is going to give you this address, right? So we have I mean basically this is why, because my pointer type is character type, and that is why this is happening. Now let's talk about. So I will be taking another example of int and all. We'll see that. Okay. Now same line. If I will say that I'm going to dereference. Okay. Now we are going to dereference the value of. So this is basically say dereference percent %c. Okay. Now let's see that what it will be. Okay. Let me basically compile this. So you see that nothing is there, right? It is kind of very empty, right? Basically, it might be having a null there. So if I'm going to say modify this little bit, say, let me just say that. what it's going to do is basically, you see the first, somewhere we have, I think, assigned somewhere A, right? That is why it is displaying the ASCII of A is 65 and the rest is 00. This is nothing but, what is the 0? ASCII of 0 is space, right? So if you see ASCII table, ASCII table, you see that 0th one is zeroth one is null. Okay, this. So now let's go back. Now let's talk about the free. When we have allocated something, now you are basically, when you're going to, now you have a 10 bytes of data, 10 bytes of memory, you can add something, you can do something there. So let's talk about the free things here. And now I'm going to do this free ptr. Okay. So we have allocated some 10 bytes of memory, and or I can say here is a, you can also have it privileges, like you can go and say that pointer cptr plus I equals to, okay, what it will be doing, what this statement is going to do.
This is
So basically this is going to initialize with A, B, C and all, right?
yes.
So if you run this, something is PPTR, CPTR. Just remove this. So we have now CPTR, and you see that basically it is kind of code. So if I just remove this one, A, B, C, D, E, F, G, H, I, J, right? Now let's talk about the free. So we have a free statement here at line number 19. So once I do this free, right, we all know that free is basically what you're going to do with the free. Free is basically going to deallocate the space which you have allocated from the heap. Now let's talk about what does it mean. Now if I'm going to do something like this, let me just copy this set of files. So we have freed this, and now I'm going to again access this. So let's see that what it is going to do. So this is basically, we have freed a pointer. Now after that we are going to allocate, I mean basically we are going to again access that pointer. So you cannot see a warning in compilation time. Now see, this is somewhere, I think, let me just add a statement so that we have freed, and then after free, after free accessing pointers. After free accessing the pointer. So what happens here? Who is going to answer? Still, we are able to access the memory, and why is we are able to see that A, B, C, D, E, F, whatever the things we have initialized before means here, right? So this is nothing but the same thing. Why is like that? Why pointer? I mean, basically we have freed it.
We are freed it, but we are still accessing that same memory. So free does release release the thing from the OS that the memory is free and other process can access it. But still we are using the memory. In case if other process gets that allocation, then there will be a corrupted memory since both will be accessing. So it
Right.
is for our safer side that we should allocate, and after allocating we free that such that it goes back to the OS memory pool.
So this is somewhere people have heard about the dangling pointer,
Yes, this is dangling pointer.
right? So what is happening? What is happening is like basically you have freed it, and still you are going to access that, right? So memory has been freed. That means it's not like that you have freed. That means this address are not belonging. These addresses are still belonging there, right? But these addresses are not given to someone, and that is why you are able to see this. Even these addresses are given to someone, and you have this basically the addresses somewhere inside some pointer variable. What will be happening is like when you're going to access or you're going to basically write something, you are going to change the. So two scenarios will be, it may line into a class or it may line in not into a class. Crash occasionally you will see. If it is the same program, yes, there will not be any crash, I think. But you are going to corrupt the memory address, basically the memory content. So the idea here is, so base part is like when you free that, when you free a pointer, what you should do is cppr equals to, okay. Now let's see the behavior. You have hit a segmentation fault. So that means why segmentation fault? Because we have freed it, and after free we have initialized this pointer with a null or zero, right? So dereferencing any null or zero address is not a.
So, why doesn't it crashes every time when it accesses a dangling pointer? Because the memory it is not belonging to this process after free, right? So
No,
why?
memory is still belonging, right? That is what memory is belonging. So memory is not free. That means say what will happen is like say two things, right? We have to understand. This is one. Whatever we are seeing the addresses, it is a virtual addresses, right? These
Mm,
virtual addresses are mapped somewhere to the physical addresses underneath, right?
yes.
Now these virtual addresses are still mapping or still pointing to the same physical addresses. So when you are giving a this type of things here, right? Basically, you are writing here, right? You are writing
Mm,
to that particular addresses with some value. So
mm,
that means the memory, it is what free says. You need to understand is free is saying that yes, the 10 bytes which you have allocated, these address ranges are available for, I mean, for use. Okay. Now,
mm.
if somebody is going to use it, yes, then you can see a segmentation fault here, or you are going to corrupt. Uh, basically, you are going to corrupt the memory content. Two things. So as of now, nobody has occupied that. Nobody has grabbed that the addresses of 10 bytes. That is why we are able to see the same content when we are using this pointer.
So that means that until someone is using this memory, there won't be any crash, right?
Right, right. But you will never come to know that who is going to write. I mean, this is a very small program, right?
Yes.
So if there is some other function or processes, right, there are a lot of processes, then this heap is common for all, right? So
Mm.
so you are not sure that when it is going to use. So that is why the dangling pointer is a tensor one.
Can you repeat what you means? Why did you say heap is common for all?
Common Heap is a common is like heap the basically when you are going to say that the addresses, right, say
Mm-hmm.
say similar addresses could be assigned for different virtual addresses. Basically similar
Okay.
virtual addresses can be given to multiple processes, right?
Okay.
Now the unique is the physical addresses, the physical addresses, but this pointer is mapped to some physical addresses right now. When you are going to say convert from virtual address to physical address, then you are going to fetch the, so you when you're going to fetch the value, basically it is going and checking whether my physical, if there is any physical address mapped to this. Yes, it knows that yes, it is mapped, and that is why it is able to give, or you are able to write something to that memory address. So for an example, suppose you have not allocated any memory here, okay, and you are bringing that, okay, now you are seeing that, okay, my 4 GB address space is available for all processes. Can I go and start writing from 0th to 4th address, I mean 4 GB address space? No. When you allocate a virtual address, when you basically create a process, what happens, the virtual address space pointer, the segment which we are seeing here, right, is basically the write, if you see that read and write permission given to that, the read and write permission given to which, to this particular address, to this particular process, right? So the permission you have given, basically this is the address ranges where you are basically you are supposed to read and write. Now if you are crossing the boundary, that means this write permission or read permission will not be there, and then you can see a segmentation fault there.
Okay. So whatever again the addresses is showing under heap, that is again not dedicated for this process, right?
Which this address,
Yes.
this is dedicated for this process, right? That is what I told.
Mm, yeah, but as you were saying, means we have allocated using your malloc, right?
So you allocated, and we have seen, right? We have allocated, and if the CPTR is basically coming, if you see the CPTR address, it is basically between this range, right?
Mm-hmm.
It is not going beyond this range. If it is
Okay.
going to cross this boundary,
Okay.
then I mean that will never be possible because it will adjust internally.
Mm-hmm.
Uh, it will make sure whenever a pointer is going to, when you are going to get a pointer, right, after memory allocation, you will always be seeing that it is belonging to this range. Now, it's like it is if a programmer is crossing this boundary, right? Suppose you started, you got some in between this. Say, now you started writing beyond this, then you will land into a crash situation. Basically, you are not supposed to cross this boundary.
Okay.
So that is why the check is.
Mm-hmm.
So if you're crossing a boundary, then that is what I said here, right? So if you are basically, if you take a look here, you are okay to write till the last range.
Mm-hmm.
Beyond that, you
Hello,
are not
Bhai.
supposed to. Yes.
So when we use free, the physical memory which was assigned to uh, the virtual address will be freed. So that physical memory can be used by other process.
Right.
It's like that, right?
Right. Correct.
Okay. Yeah.
Okay. So let's see that. So we that this is called a dangling pointer. Okay. So this is an example of a dangling pointer. Now, if I'm going to say that, what will happen if I'm going to use a two twice free CPTR? What does it do? Any guess?
So the problem here is Means you are doing first pre, and in between other processes coming and allocating the same memory, and then you are doing the second pre, so it will deallocate again. So the second process which came in between, that will face problem.
No, there is no any process as of now. So this is a single program.
Okay, so for
It
this
will
I
give an
think there
error.
won't be any problem.
Exception will be thrown.
With compilation. Compilation is perfectly fine. Okay, let's run this simulation fault. Okay, so double free is not allowed. Uh, Previous compiler, right? I mean, you may be able to see very old time, 10 years before, a few architecture dependent compiler. You can see that even in double free works. So
I think it is crashing because this one the no no.
I think because this
Can you comment this the last for block, and then if you
I commented this out. Okay, let's see that.
yeah, now it is not
So
crashing, right?
you can say that it is architecture dependent. If you just run to some different machine,
Mm.
double free is not supported by many. Okay,
Yeah, that anyway is wrong. Yeah, means not
no, you
wrong
can
means not
no,
recommended.
you
Not
can say
recommended.
that there is an exception, basically the bus error or something, segmentation fault things. Just run this, try that out. Okay. So double free is again somewhere it is valid, somewhere it is not valid. Okay. Now let's go back to uh, talk about the void pointer. Or let me just modify this program to integer. So if I'm going to allocate, say, oh no, let me just talk about the zeroth one first. Okay, then we'll go to the integer pointer. Let us talk about zeroth address. Okay, fine. So malloc with an argument of zero size. What it is going to do? Is it going to return a null or is it going to return a valid pointer?
It will return null only. It is returning null.
So we are able to see that yes, it returns something, and beyond that we are able to read and write because we are still inside the boundary range, right? But if you are going to say, can I say here -1?
So it will be very long value. So I
Mhm.
think
So what will happen?
so. It will go out of means the malloc will fail.
Okay, so see, malloc declared here external void size d through attribute malloc. So basically, malloc size larger than. Okay, so this internally converted to a large value. Now, if you're going to run this, what happens here?
So it terminated on malloc call.
So your malloc has returned a null, right? I mean, I have not added a statement here. Let me just call it null one. Not right way to write the code. Just getting this line back. Okay. So let's see that. Now just got a null address. because it is a very used size. Okay, that is why it was callable. And now let me just say a let me just change this to integer. Now if I'm going to use say, so the best part it is like if you are going to say that uh, size of int into n, what is going to do?
So it will allocate 40 bytes if integer is 4 bytes.
So you can either give a 40 bytes or you can just go with the size of int. If you are not knowing basically the best habit is just use the size of operator with the data types or with the type, and then it will be taken care automatically. Or you can manually also you can just know that okay integer is 4 bytes, I can will give 40 bytes. That will also work. So this is going to now let's see the pointer arithmetic here. The same piece of code. So we are going to get 40 bytes from the heap, and what we are doing here is pointer cptr. Pointer cptr equals to a, right? And point and then basically we are just going and writing to 10 bytes. So let's see that. Let me just comment this out. And the first is what is happening here is like, so if I will run with this same code, what is going to happen? Any thought?
So it will print means value of a 6.
No, this is there is a typecast mismatch
Okay,
here, right?
okay. So yeah.
So see, our pointer is of type integer,
Hmm.
but Malloc returns a void pointer. Now I have typecasted it to character. What's going to happen?
Hmm. I think it should not be a problem.
Mhm. So let's the arithmetic understand, right?
Hmm.
So we have compiled it and we have got a warning. We know this. What time? Let's run this.
So it is again
You see that, right? Let me just scroll it up. When we are basically incrementing a pointer,
Hmm.
you see
Hmm.
4, 8, C, 4, right? So basically the pointer is getting incremented by what time?
4.
4, right? So
Hmm.
I told you, right, when there is a arithmetic comes in between, what it does is basically it first goes and take a look into the type of pointer. Your CPTR is of type integer. So whether you here you just remove this or you typecast it doesn't matter. Okay. Now your if I'm so the nature of my pointer is integer, that is why it started incrementing 4 bytes. Now if you just go to the output, what it is doing is the first 4 bytes it has written A, next it is writing B, C, D, E. Now let me see that B and then so the same behavior with the free, whatever we have seen. Now one thing is so if you are going to work with a pointer, arithmetic. Now you can say here is like, let me just do it the reverse way. Okay, CPTR CPTR equals to CPTR plus 10. Okay. So your CPTR is going to point to which address?
The last one.
Last one. Now I'm going to say that I equals to, will this work?
Yeah, minus we'll have to do minus.
So I equals to 0, I is less than 10. Okay, fine. Let's change this to minus, and we'll print it somewhere. Let's print somewhere. CPTR. Something. Basically, if you miss the first address, what is going to happen? Okay, now this is a nice one. Now let's see that what happened here. Who is going to say that?
Valid pointer.
So let me just remove this piece of code, the last one here. So that we will be doing more. Now we will not be able to say this segmentation. Let's understand this first. Indeed. Um, okay, so let us see what is going to happen. What happened here? So size of pointer is 8 bytes. CPTR is basically 4670. What we have done here is we have basically added CPTR plus 10. Right. Let me basically open this in another window so that I can see that. Okay, so here is the so first it got printed this 8 bytes, which is fine, and we have also assigned 65 to this, which is fine. Now let's see that this line is also got printed. Address still this place is 70. This is the same address become by the pointer. Now CPTR plus 10. When you're doing a CPTR plus 10, what is going to happen?
It is so 0 plus 10. It will point to the means. If you are starting with 10, right? So means 10 plus 40, it will point to 50. So it means last in the last byte of last integer.
Okay, so here is the thing. Okay, so let's say that uh, programming mode you have 4670. Okay, 4670 is the first address, right? 4670. I mean, I'm just taking this, the last four. 4670. You're going to add these to 40, right? The hexadecimal, this is basically the hexadecimal. Okay, so let's see that. So decimal, the 40 is in decimal, okay?
Yeah.
Now you have to convert to hexadecimal. So decimal of 40. What is the hexadecimal equivalent of 40?
It will be
16.
28.
28, right? So 28 is your 6. This is hexadecimal, right? Now let's go back. So you're going to add this to 28. Now if you're going to add this to 28, it is going to be 98, right? Straightforward. Correct? So that is what the 98 address we have got it here. Now 98, you have started decrementing 94, 90, 8C, 88, 84, 7C, 78 and 74. Fine. But your CPTR is pointing to which address?
98.
98, right? Now that means
It is 24,
so if you come here, right?
40. Yeah, 40.
So this is a problem here. If you're going to change the addresses of the point, right? Say let's see that. We have changed this, but your still pointer is pointing to CPTR is the last one. Now you have started decrementing this point to CPTR. Let's understand this. We will apply the GDB and we'll see that how it goes. Malloc C. Which line it is basically? Which is the line where it is creating a problem? Who is going to answer? Not commented this code. Okay, I have commented this out. So, which is the line it is creating a problem?
So line,
Let me just put it out.
yes.
Yes. Anyone?
Yeah, can you show the code? Code is not showing, so it is on
Oh, okay.
another.
Sorry.
So here, malloc, they are updating, then so I think this one, inside for loop, we are assigning CPTR minus I, the value equal to A plus I, right?
Let me display the line number so that you will be
Yeah.
able to. Which line number?
So this 18, line number 18th. So
Line
18th
number
line
18
number.
is okay. CPTR plus %T.
No, after that 18th.
After 18, this is the
Yeah,
one.
yeah, this one. Yeah.
So what happening here is your CPTR is
last, so it is pointing to last byte of last integer, right? Means where it is everything is ending, and then there you are assigning, so that is not you have allocated.
no,
You
but
are,
it's printed, right? Say if you are thinking about that piece of code, say your I has reached to 9, okay? So pointer CPTR minus 9 is J, it is printing, right?
uh, then the this printf last one. So what error it is giving assertion old size letter.
Okay, let me just go back here. So go back. Let me open this one. Okay, now let me just how you're going to debug this. First thing is, first question is if you are landing into this situation, how you are going to debug this. All are agree something is wrong to this piece of code, or this piece of code is fine. I'm going to comment this. Okay. Now I will let's run this. Sorry. So let's run this. And let's see. Perfectly fine, right? So where is the culprit? So one thing is we have identified that this line is creating something wrong, right? Now let's figure it out. When you are going to add some 10 bytes to that, what happens in between? So all are agree that this is the line which is creating a problem. You have seen, right? Now let's talk about this line.
It will jump by 48 bytes, 40 bytes.
48.
So it jumped, right? So it jumped to. So let's see. One thing is like what we have to see here is like. Let me just run this. No, I think okay. This is fine. So let's see that whether is it crossing the memory boundary. 4607 is the one. So sudo that, definitely this is beyond the whatever the addresses we are here. So yes, 4C and all like you can see here. The addresses are within the range 563 BFCD. Now let's run another one. Okay, so let me just go here and uncomment this. And now let's debug this. I need to stop somewhere. So basically, if you notice here, it is not reaching to get care also. Correct?
Yes.
If I will add a printf statement here, it is not reaching to get care. Get care you might be reaching and crashing here also.
Abhay, you can put a print statement before that for loop. So
This
yeah,
okay.
after that assignment of CPTR equals CPTR plus 10, you can put up and there it will.
Okay.
Yeah.
So now we have changed this and CPTR is going to, I mean, we are printing the new address of CPTR. Okay.
Yeah.
So this is, let me bring this back here. CPTR. Right now. Let me,
And at least that line gets printed. We can see that one in that
yes,
maps.
this line got printed. Okay. Now let's see that. So no, let me add this here. Right before reaching here, let me put a get here.
And I don't think there it's getting a problem. It's getting a problem at that for state for loop crash.
Hmm. So basically, your for loop is the problem, right?
For loop is
So
the
so
problem. So
so when you are coming out of the uh, for loop, you are seeing a crash. So this piece of line, whatever you're going to do here is like 22 or so your problem is sitting inside this for loop.
yes. So here can you can comment out that line number 18. It should be fine.
Line number 18.
Yes.
Okay.
Yeah.
So okay.
Loop
Right.
different things.
Hmm. Yes.
Yeah. So you can see the, now let it be like this. You go to the maps and see that the TPTR whether it's getting access to the phone.
So let's see that now 4670. Definitely this address would be there.
Double five three double three double five three double
292690. Yes, these are within the ranges. 2674, right? Even 2698.
two nine six. Only 2998 296 296.
Yes, all addresses are within the range.
Okay. Okay.
So now let's
So
go
maybe
back. Yeah.
it is with our other process which is accessing it's giving the problem.
No. So we have identified that this line is basically. So let's talk about this line, right? What this line is basically here. So line number 18 is the culprit, right?
Yes.
So line number 18, what it is doing?
It is assigning value, but that should not be problem.
Hmm. So CPTR minus I, right? What it is basically happening is
CPTR minus.
what is the value of CPTR we are able to see here. The CPTR is adding some 40 bytes to the first address and then we are basically
You can,
dereference.
can you do one thing? Can you make that CPTR plus 9 whether that one pointer is doing the problem? CPTR equals CPTR plus 9 and uncomment this line.
Yes, yes, we should try that.
Then it will be definitely it will be a boundary range problem. Okay.
Okay. So uncomment this. No, no, this one line number 18.
Okay. So let's see that. Yes. Now let's see that.
Yes. So it's going beyond that. So you're adding 10 to that and you're allocating 10 bytes of memory and we are accessing the 11th byte because it starts from 0.
Right. So if you see, so this type of problem you can see if you are crossing beyond the your boundary, you can land up into this problem. So even say in the first example we have seen that I mean, even if we are crossing, say, character right, you may not see any issue, or you may see this kind of issue. So it is always good, or it is always advisable to be in your boundary. So that means, when if we are going from 0 to 9, that means that is what, if you will include 0, it is going to be 10, right? So that is a nice catch. Like, if you are crossing your boundary, you will be in trouble.
No, but still, if we are accessing a memory,
Mhm.
other boundary region, it shouldn't go to a segmentation fault, right? It's not.
Let's Okay, so let's figure it out. Okay, so let me just 10. Okay, now get that. Okay, at least we can see the addresses ranges. Okay. Hmm. It's not there. Okay. Now run this. Hmm. So you have uh, 40, so you have 5 1 5 5 1 2 3. Now this is this boundary, you can see is still 3698. Okay, so we are within the boundary. Okay, now when I am going to do something like this, this time it is okay, fine, or we have not. Okay, same piece of code, now it is working fine, right? So Kiran question was why it was crashing. So crashing this boundary, you can see, right, this boundary will never get, if you are going to print the addresses, you will be seeing that this boundary is basically, you are within the boundary. I was talking about the physical addresses.
Yes.
If your physical addresses will be getting used, then, because there are a lot of processes are running, right? I mean, this is a kind of a multitasking system, right? So multiple, basically keep on spawning. So in that time, you can see this type of issues. Now, if you run this, you may hit or you may not hit. So if your physical boundary, if your physical addresses are getting used, then you can basically see a problem there. Okay.
Yeah. So basically, the behavior is undefined. It is programmer's responsibility to.
Right. So it is. This is why, I mean, it is programmer responsibility. Then when you are allocating, so there is no any boundary check, as you see, right? Array has a basically boundary limit, right? You can use the size of operator, and you can basically come to know that what is the size you have allocated for this array. I mean, what is the size defined for this array, right? But in pointer, there is no any size. Once you got an address, now you have to know your limit. What is the range you have to basically go in between. So let me just, I was thinking to cover this pointer. Okay. So pointer arithmetic is like that. So you can basically go. Okay, so just a small program. UTR one dot. If I'm going to say int pointer UTR equals to number of one. UTR equals to percent p. now PTR, we know that PTR is this. I'm going to say that PTR equals to PTR divided by or PTR into 1. So if you see invalid operands to binary, so only arithmetic, if you even if you are going to use this divided by, okay, so invalid operands to binary, so that means it is it only understands plus and minus, no any other arithmetic operator you are supposed to use. Okay, now let's go back to the, let me just start with the array. So I will basically I will keep on jumping between array and pointer now. Okay, so we can basically now you can see the differences between an array and, so what is an array, by the way? Let me just, while I'm writing, just from your side, what is an array?
It is means sequence of similar type of data.
Sequence of, okay, what else? What is the difference between array and pointer?
And pointer, the main difference is arrays are means static. You know, means when you are writing the program, you are declaring them.
Mm-hmm.
Pointers are very dynamic type. Pointers go in a heap and arrays go on a stack.
I mean that array pointer would be a const pointer. You can't again point it to different address. That A will can't point
Yes,
to a different address,
yes,
but the pointer can point to other address.
Okay, yes, what else? So okay, so the syntax for, okay, so whatever you people have said, that is perfectly fine. So let's talk about the syntax. So you have a basically the data type. What, so array is a collection of similar elements, okay, similar types. So if you are going to, it is a homogeneous, it's not a heterogeneous like the structure and all, right? Now this is the subscript we call, right, basically the brackets, which is the square brackets. So a, you can give a subscript the size of the subscript, or you can empty it. When you are going to make it as empty, what you have to do, you have to initialize this array, right? And then automatically it will come to know that what is the size. If you are going to make this as an empty without initializing, what will happen? A, this reverse. A. Fine. Now let me just show you something here. If you are going to do like this, array size missing in A. Okay, so if you are going to, so this is one kind of initialization. So if you are just initializing array at the time of defining, you may or may not give the size. Okay, so if you are just leaving this without initialization, what you have to do is you have to say that size of the array, 5 or something, and something. So basically this is a static one. So you have now said that, now you can use like this also. That is also fine. Now let's see that when you are basically defining an array here, what is going to happen internally into the memory is this will be not from heap, right?
yes.
This is from the
Stack.
stack. So one difference is like your pointer when you are allocating it is from the heap, but here it is from the stack. Now this will be a contiguous memory.
Yes.
So basically contiguous means your first address will be pointing to one, second will be, I mean, basically it is an integer, so 4 bytes, you add that, and 2, 3, 4, 5. Now, the important thing with array is like you cannot change the base address of an array. So if I'm going to say equals to e equals to a plus 1, this will be called by your compilation. Okay. So a plus assignment to expression with array is not allowed. So because this is a constant, so one is, so this statement is invalid. Now, when you're going to traverse an array, the first thing what you have to do is, now, okay, let's understand the size of how I mean, I'm going to do this print of size of a equals to, so this is going to return, uh, say, not given any output name. So size of a equals to 20 bytes. Now you see here, this is basically a is of type integer. So we have 5 here. So 5 is the size of the array, and the type, basically the size of int is 4. So 5 into 4, it will be 20 bytes. If you're going to make it as a character, then it will be 5. You're going to basically make it as long, then it is going to be how much byte? How many bytes is it going to be? 40 bytes, right? The size of long is, I mean, if the size of long is 8, then 8 into 5, 40. Now, so you can identify that. So if you have an array, you can basically know that how, I mean, till what, I mean, till what is the end of my uh, range, basically, and how we are going to do size of a, you know the size of array. Now you divide the size of type, you will basically know the boundary type. If somebody will tell you the array name, you will be basically able to figure it out, what is the size of my array. Okay, we use size of operator, but with pointer it is not possible. Now the second point is, let's come back and see the ptr equals to a. ptr equals to a is perfectly fine, because if I'm going to do this ptr equals to ptr plus 1, what will happen? Suppose if your ptr is going to point to the base address, now ptr you have incremented by 1, which is acceptable, because still your a is pointing to the same address, right? But ptr is another point, ptr is another variable which you have basically, so you have not changed the base address of the that array. That is what it is highlighting here. Now your array is like when you basically call a function, right? So let's see that when you are passing uh, it int, say some uh, int size int a1, for int I is to 0, for I equals to 0, I is then size I plus plus sum equals to sum plus e1 of I. What I'm trying to highlight here is uh, this is a int sum, and then you can say here without sum. So when you are passing array as an argument to a function, say, so there are multiple ways to handle. And in the definition time, right? And what are the ways? What are the different ways? Who's going to talk about? Yes. So sum is a function, right?
Yeah.
Now, what we are, I mean, inside the sum, say if you just look for the prototype of the sum, it is like this sum int. What will be the prototype? Who is going to say?
The second one could be int, the same thing, function definition you have given, or it can be pointer also, pointer to integer.
So if I'm going to do like this, can you write like this?
Yes, you can write these also.
Okay. So only thing is like that the header file is missing. Now let's go back here. So this is, now if I'm writing like this, okay, if I'm writing like this, can I go and say that?
Yes, this is also fine.
So let's see that what is happening. So you can see that pointer and address are interchangeable, right? If in place of uh, an array, you are using a pointer, and in place of pointer here, right? Let us say that I'm going to change now this to in pointer. Okay, now let's see. So you can see vice versa, right?
Yes.
So that is acceptable now. So this is one way. Now when you are passing as a pointer, right? Say you are passing as a pointer, you can pass as an empty argument here. Okay, so this is one place. Okay, I will just highlight it here. So we have seen that when you are defining an array, you must have to give a size of the array, right? But when in the parameter, in the function parameter, you may or may not have the size of the array. So you can pass the size also. So if I'm going to do here, okay. So what will happen if I'm going to write the size here?
It will give an error in compiling.
Okay. So what will be happening here if I'm writing a size? What does it mean basically? You can see that now. If I'm going to, so basically, let me just change this and subscript. And now I'm going to give as a size here. Say why size is important here. What will happen now?
This should give an error. So it will not give an error.
What is the difference here?
So difference here, I think, is that if you are writing size, right?
Mm-hmm.
So it will copy. So there is a copy of array. If you are not writing, then it will just use the
Okay,
earlier.
okay. So let me just run it and then you can see the differences. Okay. So A1, this is like we have written it before. So what it is going to do in this sum function, it is going to basically add all the elements of the array, right?
Yes.
And then it is written the size. Okay. So let's see that. A or out 1, 2, 3, 4, 5 might be 15, right? 9, 3, 12, 2, 14 plus 115. Correct one, right? Now let me just go and use a size here. Hit it. So what is happening here? This program is fine, but this is basically, is this a pointer or what kind of this is? What it signifies? A of 5, A of 9. Is this a pointer or is this a general integer type variable? I think I need to include this warning
It's
already
an
in
array.
the can I write like this? Also fine, right? So what is the difference between these? So best is when you are going to pass, right? Now when you're going to, okay, let me just use this. So if you see here the size of A1, if I will be using, what will be the size of A1?
Size of A1 here, if you are mentioning 10, then it will be means 10 into size of int.
You see that size of A1 not declared here. Understand, size of an array function parameter A1 will return size of int pointer, right?
Okay. So it will be one means
So
8 byte only.
you are going to, yes. So though you are using this as a, even if you are passing here as a number or uh, empty one, right? It is basically, it is going to treat as it is as a pointer, okay? So it doesn't matter. Basically, what I was trying to highlight is like you pass it or you don't pass it, it doesn't matter. So the best,
So there is no difference. You are
there is no
passing
difference.
anything.
Yes. So it will be treating as a pointer, basically. Now the best thing is, so that is why if you notice we have passed the size here. That is
Yes.
the purpose of passing a size here. Otherwise, if it is able to figure it out the size of an array here into the this function call, then there is no requirement to pass this first argument, right? Just figure out the size and then you can go ahead. So when you are passing array as an argument to a function, you should also mention the size because you will not be able to, because that will be treating as an integer there. Okay. So this is one place where you can have an empty array. Now,
Hello, Abhay. Is it same as integer pointer? Like if instead of in the sum arguments, yeah, if
mhm,
I have int a1 square bracket, instead of that, if I just pass it as an integer pointer, will it be same? Both are
Yes,
same.
it is
yes,
same.
yes, it is same. But if you're going to pass this as a1, right?
Yeah,
It's
it's
going to
both
be
are
same.
same.
Yes.
But in this case, we can point the a1 can point to other address, but if in that case, it won't be able to point to other address, I guess.
Sorry, which case?
in the previous case, like if in the like passing it as an array,
Mm-hmm.
then it won't A1 can't
Ah,
point to other
okay,
address.
okay. So let's understand that also. Okay, so you are saying that A1 is like
Yeah.
this.
And if I want to point it to other address, A1 plus equal to A1 plus 1.
So what is A1 here, right? So okay, so let's print that. Okay, so printer, we have A address in main function printed. Now let's see that A equals to percent %p. Okay, okay, sorry, A1. Is it the same address or is it going to be different? Different one.
It will be same.
Same, right? So it's kind of a reference here, right? So it's like a basically a reference here. So whatever
Okay.
you are passing here, so that is why this is treating
Pointer.
as pointer, not as an array here. So whether you pass the
But
size,
if I pass it as a pointer, then the value would be different. Then the address will be different, right? If I pass it as a pointer,
that doesn't matter, right? Your base
the address.
address, the name of the base the name of the array itself is a pointer. Okay. So okay, so
Uh,
just a minute. Let me just a address of a. Fine. So if you see both three print, right, a address of a address, I mean a1 is going to give the same address, right?
okay.
So this is basically, so this will be always treating as a integer, I mean sorry, pointer. That is why you need a, when it is a pointer, now you don't know what is the, basically what is the size of, I mean till what extend this I can go and fetch the address, fetch the value of the addresses. And in place of, so these are the interchangeable. Okay, so in place of, so in place of this you can also change, basically and also write it like this, plus, so pointer a1 plus a. This is also okay. Okay, so a of I subscript you can replace with this also. Fine. Sum equals to 2. So this is how you can interchange a pointer and an array. So it makes sense into the function definition, but whereas I mean these things you can put it here also. So for an example, if I'm going to traverse this array, for an example, like say uh, here I'm going to traverse say, or how you're going to traverse an array is using a variable or using a formula. Is now I don't worry about. What you have to do is size of a divided by size of int, right? And plus plus, and then print out. So how you're going to fetch the value is a percent d equals to percent d, since it is an integer one. So a of I. So you have to traverse that array. So that is why that algorithm starts, right, traversing. So basically when you're going to traverse, you have to start in the first address. So we are traversing and printing all the elements of the array. Now run this. Okay, looks like one this is missing. 1 2 3 4 5, right? So let's see that if you're defining an array of size 5, basically array starts from 0 and it will be n minus 1. So remember that. So 0 till 4. So I mean basically if you count this, yes, you have a sufficient basically 5 elements for the array. So if you are defining 1, it will be basically you are going to say that you will define only 4y. So you will be a0. Now there is no guarantee that, so it's like you can cross the boundary of an array. What you are going to do, say if I'm going to say here, remove all into 2. That means, let's see, you cross the boundary of that array, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Basically into 2 I did, so it will be 1 to 10. So it is not, yeah, it will not tell you that okay you have crossed the boundary, so you're not supposed to use. So you again you have a kind of a, you have to make sure that there is no any boundary check with the array. So it is programmer responsibility again. Yes, but compared to pointer, you will have thing here that you come to know that what is the size of my array. Okay, so let's move on. I will just give me more 5 minutes. I will just. So this is how you can keep on interchanging. Now this is like, so we all know that when we are going to store this is going to be the basically let's see the addresses here. If I will write this, what will happen? So this is like uh, when you are putting a subscript, basically it is going to dereference that. Okay, and adding like this is going to give me the addresses. So it is a contiguous as we said. So 40, 44, 48, 40, 50. Right? That is how. If you just go and see this addresses would be part of your stack. Mm, 5543. 7FFC 40404, yes, 40 and 4FF is within this 7000. Okay, so this is part of your stack, it's not part of your heap. Now, so there are another way is like people go and say that two-dimensional array you can make as a two-dimensional array. So when you're going to make this as a two-dimensional array, what does it mean? What this means is like when you're defining an array of like say a 4, what is going to do? how many bytes, first of all, how many bytes of memory will be allocated for this if it is an integer? If a is an type of integer, how many bytes of memory will be allocated?
It is 5 into 4 into 4.
Yes.
It,
So that means 80 bytes, right? 80 bytes of memory will be allocated, and this 80 bytes will be contiguous or non-contiguous?
contiguous.
Contiguous, right? So you have a facility that you can go and say that now if I'm going to do like this, right? I'm going to let me just comment this out. So here, can I just make this like I just said? Is it acceptable? Yes or no? Will this work?
Uh, yes, and the second, what we call, will be initialized with zeros.
So what will be the size of array here?
Two times of means 80 bytes.
Uh, okay. Okay, so this is an interesting one. Okay, so if you are going to compile this, it may throw an error. So it's saying that array type has incomplete element type int. So what is basically, if you see declaration of A as multi-dimensional array must have bounds for all dimensions except the first. That means
The second subscript should have value.
so if you're going to say 4, 5, 5. Now let's see. It's happy now. But yes, again, this is kind of a saying that you have to put another curly braces inside this, right? So what is important, what I'm trying to highlight here is, sorry, the important part is the first people say that the first is row and column, right? I mean, for understanding most of the places you can see that people say that row and column. So if you are going with that terminology, which is mandatory here is column part, okay? The second subscript. So if you just pass this, then your compiler will be happy. If you are just removing and passing it here, it will not be happy. So, like see. So the second is mandatory one. You can make the first one as an empty, or you can pass this as a. I mean, this is also. Whereas in the single, in the basically one-dimensional array, I mean, you can make it as an empty. But in two-dimensional array or the multi-dimensional array, you have to basically take care of your last subscript. So size is mandatory basically. Now, if I'm not going to give this size, here, right? So what will be the size of array here?
So it is 1 into 5 into.
Hmm. So let's see, this is interesting. Size. What will be the size of here? So the size will be 20 bytes.
Yeah, 5 into 4, 1 into 5 into 4.
Now, I'm going to put this as a 4 here. Then it is going to be
80.
80 bytes, right? So you can see here, we're not putting the size here. What it is going to do, it is just how much the element here, it will based on that it will be locating the size, right? The size is getting calculated internally. Basically if you are just initializing with the more elements, your size might will, your size will be changing, okay? So you have to take care of that when you're initializing. If you're not initializing here, this is also perfectly fine. But this is, will this be allowed without initialization?
This should be error.
Yes. So this is not supported basically. So at the time of initialization only you can do this. Otherwise you have to specify the size. So now if you see the size here, what it's going to do is it is going to so see here size is dash printed 80 bytes and it is a contiguous block basically. So AF0, AF1, what is this? This is 14 bytes, right? So this see that 14 is what?
So this is 1 4, right? So
This is 20, right?
20, yeah, 20.
So this is like it is not what is happening here is like it is not in we were expecting that the next byte will should be 104, I mean according to this,
Yeah.
but this is printing something might be 104 somewhere. No.
No, here
So
it
so when
is,
you so when you're dealing with a two-dimensional array,
yeah,
you basically the traversing should be first you should basically traverse. So if you are traversing like this, what you have to do is, so here comes something like uh, size of size of this is going to how many bytes is it going to give? 20 bytes, right?
yeah.
Now how you can print this with this statement? I don't want to use this I and j concept. Like I don't want to basically traverse to row and column and then print it. Can you do with this a single for loop?
Mm,
Think of
so 20 to the printing, 20 times. Yes. We can print A0 plus I, means we can write here A0 plus I.
a0 plus I.
Yeah. A0.
But it will always be adding, right? So okay, let's see that. Okay, so let me just go by this. Let's see that. C0, C4, yes, CH, CC. So what he suggested that he basically he proposed that take the base address and keep on adding to that.
Yeah.
So that is one aspect. Other aspect you can take a pointer and you can do that, right? So or you can, I mean, traditional approach like how we have studied here, you can have a two loops, I and j. One will be running for the row and other will be running for the column, and then you can do that. Right? That is another way. So this is like even the multi-dimensional array will be going with the contiguous allocation, right? And so basically we need to stop it. It's going to be 2.5 hours. So here also we can basically like the single pointer we can go and use a pointer arithmetic also here. Okay. So we need to basically now if you are going with a multi-dimensional, which will be the pointer arithmetic? If I will be using ptr equals to a, you might see a warning somewhere. Right? If this 9 number says any 11, you are seeing warning somewhere. Right? Just compile. Incompatible pointer type. Right? So this is basically it's saying that the PTR is a
Pointer to
pointer which is not a compatible here. If I will make this, how to basically suppress this error?
So we can add brackets there, or we can make double pointer.
Okay, if I'll be making a double pointer, let's see, we'll go with that. No. Okay, so let's uh, the, the second approach is suggested. Let's make it as a pointer to an array. Okay, let's see. This is happy now, right? So this is a pointer to an array, and what is called, and basically something called array of pointers. So let's understand the syntax. Okay, so array of pointer will be denoting like this here.
Yes.
So this is the difference between why we are putting a bracket here is
Because we are making a pointer to array, and this is array of pointer, second one.
yes. So this is like when you are putting a parenthesis, this is going to be related first. Okay, this is pointer. Okay, now what will be happening here is like your subscript has the highest precedence than this.
Yeah.
So this will be basically, and this will be treating as a
Array of
this
pointers.
in pointer. Okay, but here this will be treating as a first, and this will be the second. So this is the second. This one is array of pointer. This is pointer to an array. Now this is happy because it knows that A is multi-dimensional array of this 4 into 5, and my pointer to an array is also pointer to an array of 5 integer, right? Pointer to an array of 5 integers. So it is basically happy. So if I'm going to ignore this case, let's say that if I'm going to make this as empty, what will happen here? Will this be okay? Oh, sorry, no, this will not be okay, by the way. Let's when I was trying to do something else. Okay, I was thinking this like this. What will be happening? Will this be acceptable?
It should.
No. Here it is PTR, something wrong. PTR equals to PTR plus 1. What is that? So PTR equals to PTR plus 1 is wrong here.
Okay.
This statement is fine, right? So you cannot. So if I'm going to comment this, right, for time, let me just. It's fine, but when you're going to perform an arithmetic, right, then that time you can see a error there, because this PDL, it doesn't know that okay, this is kind of an empty array. How long? I mean, till which? Till if I'm doing an addition of 1, where I should go to the next. So this is why it is basically invalid use of array with unspecified boundary. Right? So you need to specify a boundary when you're going to use this. If I'm going to make this as a 2, what will happen? Let's see that this is again incompatible. Unless it matches the size, it will not be compatible. So if you match the current size, it will be happy. APTL basically we have defined, but we have not used. That is why it is. This is your array of pointer and pointer to an array.
I think it's a maybe because A is a const pointer and the PTR is a normal pointer. Because of that, it might be throwing error. Like if you make a PTR as a const pointer, it might not throw error.
Which one you're talking about? If I remove this size and then
I mean, it's just keep it as a normal pointer and just make it as a const pointer. Like
which
The declaration he is saying, but that
in the declaration, yeah.
here this is const.
Yes, and remove that bracket, yeah.
Remove which bracket? This bracket
The square brackets.
or this one? No, it doesn't make so. Even if you're going to do this, right? The PTR, constant point PTR, right? What will happen?
I mean, maybe because of that, it's showing incompatible assignment. Like because
Ah,
A is a,
so you see that now. It's an incompatible because
It's
this PTR equals to A. The type of things you are assigning to this pointer is of what type?
array.
It's an array of 2 dimension, right? If it is an array of 1 dimension, then
Then it's
perfectly fine.
okay, okay,
But if it is an array of 2 dimension, then yes, then it's definitely you have to basically uh, use this as a pointer to an array, and this is where your pointer to an array is basically coming into picture. When you're going to deal with the array stuff multidimensionally, then you're going to make use of this. Okay.
okay.
So let's write an assignment with this current things. What you have to do is basically uh, you have to allocate a memory for. So basically, uh, you have to allocate a memory for. This is going to be a complex one. We have not discussed this double pointer, but so with this pointer to an array, let's uh, play with the arithmetic. So your assignment will be using this ptr equals to ptr plus 1, right? Ptr is a pointer to an array of 5 integer. When you are going to do a ptr plus 1 or ptr minus 1, basically ptr minus 1, what is going to happen? And when you're going to say ptr plus 10, or you just run a loop for I equals to 0, I is less than 10, and then you do a ptr equals to ptr plus plus or ptr equals to ptr minus minus and see the behavior. Okay, so shall we stop it today?
Yes.
Any doubt?
Yeah, yeah.
Other assignment would be let's basically write some program with the array and this try to print this 2 dimensional array using this uh, into this matrix format, right? Matrix format is like, so you have a multi-dimensional array like say, so you add the, so okay, so right the question is like, so this is like, this is going to be 1 2 3, right? So if this is a 2 dimensional array, uh, basically this is 2 into 3, right? 2 into 3 array, 4 5. So we have 2 rows and 3 columns, right? This is something called as a row. This is like a column, right? So what you will do is you have to add all the elements of this matrix. Second is like, you have to basically, what you have to do is you have to add this, add this, and add this. Got it? So first is like you add all the elements of the matrix. Second is you add the row, the row, and see that which is the biggest, uh, uh, the biggest sum of your basically this column, which is the biggest addition in this column. Just return that. Okay, got it?
Yeah.
Yeah.
So try that out, and again we'll meet tomorrow.